We are going to be working on reviewing operations with fractions today. So adding, subtracting, multiplying, and dividing with different fractions and mixed numbers to get ready for our test tomorrow. So before we get started, I want to review a couple vocabulary words. So first we have this word expression. An expression is just setting up the problem you are going to solve. It has numbers, variables, possibly, and an operation. It's just telling you what you're going to do. So if I had 3 apples and then I got 4 more apples, I would have to do the problem 3 plus 4. So it's just what problem are you doing? What represents the problem? If I want to find an equation, equations have to have equal signs. Expressions do not have equal signs. So if I showed I had 3 apples and I got 4 more, I would have 7. So equations have to be the same on both sides. 3 plus 4 is 7. 7 equals 7. So equations need equal signs. Expressions just tell you the problem. Hey, if you do not have a paper and a pencil, you're going to want to pause and go grab a paper and a pencil so that you can do these problems with me to be able to do your best on your review and on your test tomorrow. So first we are going to write the multiplicative inverse of 4/5. So 4/5, when I use the reciprocal, makes that 5/4. When I multiply this fraction 4/5 by its multiplicative inverse, 5/4 is 20. 5 times 4 is 20. 20 divided by 20 is okay, so we have this problem 4/5 divided by 3/7. What process do we need to solve this problem? So I can't just do 4 divided by 3 and 5 divided by 7, but I can use the multiplicative inverse or its reciprocal. So I would need to copy dot flop. So if I was doing this problem, I would want to keep the first part the same. The opposite of divide is times, so the multiplicative and inverse just means the opposite, 7/3. Then I could multiply the numerators and the denominators. So let's take a closer look at what a multiplicative inverse means. So we have this fraction here, 4/5. If I write the multiplicative inverse of 4/5, I multiply by 5/4. When I multiply this out, 4 times 5 is 20, and 5 times 4 is also 20. 20 divided by 20 is 1. So when I multiply a fraction by its multiplicative inverse, the answer will always be 1. And when I times something by 1, it means it's going to be itself. So when I divide or times by the multiplicative inverse, when I use that copy dot flop, we're getting the same answer. So multiplicative inverse will always equal 1, which is why we can, instead of dividing, we can multiply. So copy dot flop, and we'll get the same answer. So we're going to solve this problem here, 6 2/5 divided by 4 2/5. Now, I cannot just divide as it is. We are not going to get the right answer if we do it that way. We need to see how many pieces we have and then put them into groups of these pieces. So I use an improper fraction or a fraction greater than 1 to do that. 6 times 5 is 30 plus 2 is 32/5. My denominator stays the same. And I'm dividing by 4 times 5 is 20. Plus 2 is 22 over 5. Now I need to copy, dot, flop. So this is where I use that multiplicative inverse. So we want to do some simplifying by the greatest common factor first. So 5 and 5 have a common factor of 5. 5 divided by 5 is 1. 5 divided by 5 is 1. 22 and 32 also have a common factor of 2 because they're both even. 22 divided by 2 is 11. 32 divided by 2 is 16. So 16 times 1 is 16. 1 times 11 is 11. And then 11 goes into 16 one whole time. 1 times 11 is 11. To get from 11 to 16 is 5 more pieces out of 11. So when I have 6 and 2/5 divided by 4 and 2/5, I can make one whole group with 5 11ths left over. Okay, so make sure you are doing these problems with me and writing them down to practice. So Carmen spent 6 3/4 hours at soccer practice last week. So I know soccer is 6 3/4. This was 1/5 of the amount of time she spent at school. So now we have school is, okay, so this number here, it says this number is 1/5. So that means this number has to be smaller. She spends less time at soccer. So that means I need to make this bigger. So when I do this here, I need school. There's a couple things I could do. I can multiply by the multiplicative inverse here. So when I take school, well, first I'm going to take soccer, and I'm going to divide by 1/5. That kind of sounds backwards because I'm hearing this word of, but I know school has to be smaller. 1/5, or sorry, soccer has to be 1/5 smaller. And school, the opposite of 1/5 is 5 times bigger. So 6 times 4 is 24, 25, 26, 27 over 4. And I'm going to times that by 5 over 1. I need to make school 5 times bigger. So when I use that multiplicative inverse, we get our answer here. So I need to do 27 times 5. So go ahead and see if you can pause the video and do 27 times 5. So there's 10, 11, 12, 13. So we have 135 over 4 times 1 is 4. So now I need to simplify this problem here. So 135, we're cutting it into groups of 4. So see if you can stop at the video and finish this problem. So 4 goes into 13, 3 whole times, which is 12, 1 left over, bring down my 5. 4 goes into 15, 3 times, which is another 12 with 3 left out of 4. So she spent 33 hours and 3/4 of another hour at school. So let's double check. So Carmen spent 6 3/4 hours at soccer practice. This number of soccer is 1/5 of the time she spent at school. So I know school has to be bigger, 5 times bigger. 33 3/4 is 5 times bigger than the amount she spent at soccer. So those are kind of tricky. And you need to think about which number should be bigger. So since we needed a bigger number, we knew we had to multiply, but we had to multiply by its reciprocal there. Okay, let's try this next one. Terry is making 6 cakes. Each cake needs 3 1/4 cups of sugar. How much sugar does she need to make her cake? So we have 6 total cakes. Each cake needs 3 1/4. How much total sugar does she need? So I want you to see if you can set up an expression of how you would solve this problem and then come back and see what I do. So I know she has 6 cakes that she needs to make, and each cake needs this much, and I want a total. So I could do 3 1/4 plus 3 1/4 plus 3 1/4, and I could do that 6 times. An easier way when I'm hearing repeated addition is to multiply by 3 1/4. You could have also written 3 1/4 times by 6, and it would get you the same answer. So pause and see if you can finish this problem by making 3 1/4 and 6 improper. So 6 over 1 times 3 times 4 is 12, plus 1 is 13 over 4. And I keep them just like this. So we can't use the reciprocal here because we're not dividing. So I need to do 13 times 6. So pause and see if you can do that. So there's 18, 6, 7. So we have 78 over 4. And now I need to see how many times 78 is divisible by 4. So 4 goes into 7 one time. There's 3 left out. There's my 8. So 4 goes into 18 9 times. 4 times 9 is 36. 2 left over. 4. I know 2 is half of 4. So to make all of her cakes, she needs 19 1/2 cups of sugar. Okay, so we knew we needed to multiply because she was doing it every time she made a cake. She made 1 cake, 3 1/4, 2 cakes, 3 1/4, 3 cakes, 3 1/4. So total 19 1/2 cups. Hey, Lacey bought 6 1/3 yards of green fabric and 7 3/4 yards of red fabric. How many yards of fabric did she buy? So she did this and this. It wants us to put them together. So see if you can write an expression that would match this problem. Hey, so I would put 6 1/3 plus 7 3/4. On this one, it won't matter if you put the 7 in front, but when I'm adding, I usually put them in order. So I need a common denominator since I'm adding. I can't put pieces of 3 and 4 together. They're just not going to mix. So I need to find my least common multiple. So 3, 6, 9, 12, 15. So I'm just skip counting here. 4, 8, 12. So we have 12 as our least common denominator. So I'm going to rewrite my fraction. So be sure to do this with me with denominators of 12. So how did we get from 3 to 12? We times by 1, 2, 3, 4. So 1 times 4 is 4. Then how did I get from 4 to 12? I times by 1, 2, 3. 3 times 3 is 9. So I have 6 plus 7 is 13. 4 plus 9 is also 13. And my denominator stays the same as 12 because we made it into 12 pieces. Now I notice here in my fraction, I have an improper fraction. So we can't leave it like that. So 12 goes into 13 one whole time. 1 to get from 12 to 13, there's 1 left out of 12. So I had 13 pieces. Now I have 1 more. So my final answer is 14 1/12 yards of fabric. Hey, we have Yolanda making friendship bracelets for herself and 6 of her friends. So we've got all those people are getting friendship bracelets. Each bracelet takes 1/3 of a yard. So a bracelet is 1/3 of a yard of string. She has 2 1/9 yards. Does she have enough string to make bracelets for everyone? So see if you can set up what problem you would do to start this and then come back and see what I would do. So I know she has 2 1/9 yards. She has this as her total. And every time she makes a bracelet, she uses 1/3. So I am splitting up my total into thirds to see how many bracelets she can make. So 2 times 9 is 18 plus 1 is 19 over 9 divided by 1/3. So now I can use the reciprocal, 19 over 9 times 3 over 1. So I'm going to use the greatest common factor of 9 and 3 to divide. 3 divided by 3 is 1. 9 divided by 3 is 3. So now I have 19 times 1 is 19. 3 times 1 is 3. So 3 goes into 19 6 whole times. 6 times 3 is 18. To get from 18 to 19 takes one more piece out of 3. So let's go back and check out our question to make sure our work matches our answer. So does she have enough string to make bracelets for everyone? So the question didn't ask how many bracelets she can make, which is 6 1/3. It wants to know, can she make enough for everyone? So if she's only giving them to her friends, she has 6 friends, then yes, she has enough. But she's also making a bracelet for herself. So she's actually making 6 plus 1 bracelets. She wants 7 total bracelets. So no, she does not have enough to make another bracelet for everyone. She can give them to her friends, but she only has 1/3 of a yard left of string. And so 1/3 of a 9th, I should say. So she does not have enough string to make enough for everyone. She would have to go buy more string to make that last bracelet. Hey, what factor would represent x? So we have this problem, 4 1/5 times x equals 7/10. So notice we are timesing, we are multiplying. So I want you to pause this video and see if you can figure out what x would be, and then I'll talk about how I get to x. So I know I need to make 4 1/5 an improper fraction. So 4 times 5 is 20 plus 1 is 21 fifths. And I need to times it by something to make 7/10. I'm actually going to erase this here and put a fraction line here. I know I've got to get something. So we're just going to multiply straight across. So first I'm thinking, well, I know how to get from 5 to 10, super easy. I'm going to say that's not 3. I don't, whoops. 5 times 2 is 10. But 21 times what makes 7? Well, there's not an answer here that is going to nicely make 7. I would have to times it by 1/3, and I can't have a fraction in a fraction. So that just is not working. So let's try another strategy here. So I'm going to think of equivalent fractions here. I'm going to times these both by 2. So there's 20 and 14. Can I get from 5 to 20? Yes, times by 4. 21 to 14. That's still not working. So So let's try our next equivalent fraction. So 10, 20, 30, 7, 14, 21. Can I get from 5 to 30? Yes, I can times by 6. 21 times what would be 21? 1. Let's try that out. We've got 1 and 6. So if I do 1 times 21, that equals 21. 5 times 6 is 30. And when I simplify and divide them both by 3, 21 divided by 3 is 7. 30 divided by 3 is 10. That equals 7/10. So I would need to times that by 1/6. So that's one way to think about it, is to find these equivalent fractions. Another way I thought about it was, I know I needed to do the opposite of times to find this number. So I can take 4 1/5, which is 21 over 5, and I'm going to divide it by the answer of 7/10, because I know I'm working backwards. The opposite of times is divide. So now I am taking 21/5, so copy dot flop here. That's a 7. So I'm going to do some dividing by common factors. 1 time and 3 times. So 6 over 1, but then remember I'm doing everything the opposite, which is 1/6, which is what we found. So there's a couple ways to find these. We can either just try and make an equivalent fraction that they both went into, or I can do the opposite of times, which is divide. And then once I find my answer, do the backwards reciprocal of the answer. Since when you work backwards, you do everything backwards. So a couple ways to do that problem there. Okay, so why don't you go ahead and try 3 3/8 times what would be 3/8. So go back and look at those two strategies and try one of those, and then come back and let's check your answer. So I know I need to make this improper. So 3 times 8 is 24, plus 3 more is 27. Out of 8 times something equals 3/8. Okay, I can get from 8 to 8, but I cannot get from 27 to 3 by doing a nice whole number. So I'm going to make some equivalent fractions. So 8, 16, 24, let's go one more. So I'm just skip counting here, 32. 3, 6, 9, 12. Oh, I still don't think we have one here yet. So let's keep going. So 3, 6, 9, 12, 15, 18, 21. Nope, I still can't get to 27 here. 24. Ooh, I'm going to run out of room. 27. Oh, I can do 27 divided by 27. So I'm thinking it's got to be this one. So 8, 16, 24, 32, and 40, 48, 56, 64, 72. So we had to do times 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get from 8 to 72. So my denominator is 9. It's me. So 8 times 9 is 72. 27 times what is 27? 27 times 1. So 1 times 27 is 27. 8 times 9 is 72. When I simplify those, it equals 3/8. So that's one way to think about that. Another was to take our problem and do the opposite, work backwards, which means divide by 3/8 our answer. So I need to copy dot flop And these 8s cancel out to 1s. And 3 and 27 have a common factor of 3. 3 divided by 3 is 1. And 27 divided by 1 is 9. So 9 over 1, but I need the opposite, which is 1/9. So I would plug this back in and double check myself. So I said 28 times 8. If I just did that times 9 over 1, I'm going to have 27 times 9 is 27 times 9, 63, 18, 19, 20, 21, 22, 23, 24. Then I'm going to have 243 over 8. And that is not going to simplify to 3/8. So you've got to remember to plug it back in and see if it works. When I plug in 1/9, I know that that will work. 27 times 1 is 27. 8 times 9 is 72. Divide them both by 9. 27 times divided by 9 is 3. 72 divided by 9 is 8. Okay, so a couple ways to think about those problems there. Hey, the floor in Marquesh's room is 25 and 5/8 feet long. He is laying down hardwood floors. Each wood plank is 3 and 7/16 feet long. How many whole boards will fit across the length of this floor? So I know the whole floor is 25 and 5/8 feet long. And he's laying down a board that is 3 and 7/16, and they want to know how many of those are going to fit across the floor. I'm noticing a couple question marks here. So first, let's just solve our problem, and then let's go back and make sure we are answering all of our questions. So I know my total is 25 and 5/8, and we're dividing by 3 and 7/16. So I need to do some improper fractions here. So I need to do 25 times 8. Well, I think of 25 as quarters, and I can count by quarters 8 times. So 25, 50, 75, 100, 125, 150, 175, 200, plus 5 more is 205 over 8. And we're dividing by 3 times 16. So I'm going to, don't know my 16, so I'm going to multiply. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. 48 plus 7 more, 48, 49, 50, 51, 52, 53, 54, 55. So 55/16. So now I need to copy the first one, the divisor, dot, keep the dividend, flop the divisor. I said those backwards, I'm sorry. And I'm going to use a common, whoops, I did not flop. I got a little carried away there. So 55. So important to check that we wrote down the right thing. So I'm going to use 8 as a common factor to divide. 8 divided by 8 is 1. 16 divided by 8 is 2. And I notice these both end in 5s. So 55 divided by 5 is 11. 20 divided by 5 is 4. And 5 divided by 5 is 1. So 41. So 41 times 2 is 82. 1 times 11 is 11. So 11 goes in there 7 whole times. 11 times 7 is 77. To get from 77 to 82 takes 5 more pieces out of 11. So now let's come back. We have an answer here. Let's come back and answer our questions. So how many whole boards will fit across the length of the floor? So how many whole pieces do we have? 7. So they can fit 7 whole boards on the length of the floor. What fraction of a board will he need to finish? Well, he'll need 5/11ths of a board. So he'll need 5/11ths of a board. How many boards will he need to complete one length of the floor? So how many boards total to get all the way across? So we know if he only uses 7 boards, he has this gap here of he needs 5/11ths of a board. So he needs to get out another board. If he just uses, you can't have 5/11ths of the board. That's not a board, okay? That's a part of a board. So in order to finish the whole floor, he needs to get 8 boards. Is he going to use all 8 of them completely? No. But if he only buys 7, that's not going to complete it. And most stores aren't going to sell you just a part of a piece of a floor. You'll have to buy 8 to make sure you have enough there. Hey, Angelica had 3 4/5 feet of a board. She went to the store and bought another 9 1/4 feet of a board. How many feet of a board does she have now? So she had 3 4/5. She bought another 9 1/4. How much does she have now? So we want to put those together. So go ahead and pause and see if you can write an expression to match this problem. Hey, so I know I have 3 4/5, and I'm adding on 9 1/4. When we add, we've got to have common denominators. So pause and see if you can make common denominators for 4 and 5 and rewrite their fractions. Okay, so the common denominator for 4 and 5 is 20. So 5, 10, 15, 20. The first number they both go into is 20. So 5, 10, 15, 20 goes in there 4 times. So 4 times 4 is 16. 4, 8, 12, 16, 20. That's 5 times. So 1 times 5 is 5. So now I'm adding my whole pieces. 3 plus 9 is 12. 16 plus 5 is 21 out of 20 pieces. So I'm noticing I have an improper fraction here. So 20 goes into 21 one whole time with 1 out of 20 left over. But I already had 12 whole pieces, so now I have 13 and 1/20 is what she has now. Hey, Stevie lives 8 1/5 miles from the skate park. This number, when it says this, it's talking about 8 1/5. This number is 1/6 of the distance. Sorry, there's a typo in there. Of the distance she lives from Ogden. So we know the skate park is 8 1/5, and Ogden is 6 times farther because we're taking the reciprocal of this. We know the skate park is closer than Ogden. So if I take 8 1/5, I need to times that by 6. So if 5 times 8 is 40 plus 1 is 41/5, and I'm timesing that by 6/1. So up here, I could set this up different. I could take 8 1/5 and I could divide it and see how many groups of a 6 fit in there. But once I copy dot flop, I'm doing the same problem, timesing by its reciprocal of 1/6. So dividing and timesing are going to get us the same answer as long as we set up the problem correctly. This is what we have. We're seeing how many groups of a 6 fit into 1/5, or saying that it is 6 times more. So I'm going to do 41 times 6. So go ahead and see if you can do that and then come back and check. So that's 246. And I'm dividing that by 1 times 5 is 5. So go ahead and pause the video and see if you can do 246 divided by 5. It's in there 4 times. 4, bring down the 6. That goes in there 9 times. It's 45. So there's 1/5. So to get to Stevie's house from Ogden is 49 1/5 miles. To get to the skate park, it's 8 1/5. And this number 8/5 is 1/6 of 49. So Ogden is farther than the skate park. So my answer makes sense. Got to go back and check and see what is the question asking you to do. Hey, we're going to decide if these are true or false. So we're dividing here, so we need to make them improper. So 8 times 8 is 9, 10, 11 over 3. So that looks good. 6 times 1 is 6 plus 5 more is 11 over 6. And we need to flip that. So 11/3 times 6 over 11 is true. Okay, 4 times 5 is 20, plus 1 more is 21 out of 5. That looks good. 4 times 2 is 8, 9, 10, 11. 11 over 4, which is what they have here. But notice this was supposed to be times, so we would need to times it by 4/11. So that one is false. They forgot to flip. They just did copy dot copy instead of copy dot flop. Okay, let's check out this last one here. 8 times 2 is 16, 17, 18, 19, 20, 21 out of 8. And we're dividing by 6 over 1. So this should, they've only got 16 over 5. It looks like they forgot to add in their 5 extra pieces. So we know that one is not true either. Okay, so you are going to work on your Module 3 review on your own to get ready for the test tomorrow. If you get stuck on any questions, please let me know so I can help you before we take our test tomorrow.